What you're about to see comes straight from NASA's own archives, unaltered original frames, Apollo 12, Apollo 17. We're going to walk through each object, break down the science, and ask the questions serious researchers have been asking for decades. What exactly did these astronauts photograph? The scientific response to something unexplained is not to dismiss it. The scientific response is to describe it accurately, consider all candidate explanations, and hold the question open until the evidence points somewhere definitive. That is exactly what we are going to do today. The photographs before you were taken during Apollo 12, November 1969, and Apollo 17, December 1972. Both missions landed on the lunar surface. Both produced thousands of frames of 70mm Hasselblad photography. And scattered through that archive, if you look carefully, are objects that appear above the lunar horizon that do not correspond to any hardware, any known celestial body at that angular position, or any obvious photographic artifact with a clean conventional explanation. Object 1. The vertical blue streak, Apollo 12. Take a look at this object from the Apollo 12 mission, image 1 in today's set. The lunar surface is in frame. The shadows of two astronauts stretch across the regolith in the foreground, and just above the horizon, at the right edge of the sky region, there is something that requires a zoom to resolve. The inset shows it clearly, a vertical blue luminous streak, elongated along a roughly perpendicular axis to the horizon, with brighter concentration toward the lower portion. What could this be? The first candidate, and always the first candidate in archived space photography, is film artifact. The Hasselblad cameras flown on Apollo used Kodak thin base film magazines that were loaded and unloaded in vacuum conditions. Film scratches, static discharge marks, and emulsion anomalies were documented across the Apollo program. A vertical blue streak could theoretically result from a static discharge event during film advancement. This produces what photographers call a lightning bolt artifact, usually blue shifted due to the spectral characteristics of triboelectric luminescence in silver halide emulsions. However, take a look at the morphology again. Static discharge artifacts tend to be irregular, branching, or diagonal. This feature has a coherent vertical structure with an almost columnar appearance. That is worth noting. Second candidate, lens flare from solar reflection. The sun was above the horizon during all Apollo EVAs, obviously, and the Hasselblad lenses, while excellent, were not immune to internal reflections off equipment, suit material, or the gold-coated visor of the photographer's helmet. A specular reflection caught at the right angle could produce a localized blue artifact in the sky region of the frame. Third, and more interesting scientifically, charged particle interaction with the film. The lunar surface environment is bombarded by galactic cosmic rays and solar energetic particles. Unlike on Earth, there is no magnetosphere, no atmosphere, no protection. High-energy particles passing through film can produce tracks, elongated marks that follow the particle's trajectory through the emulsion layers. These are well documented in space dosimetry research and were in fact studied deliberately using film brought back from Apollo missions. A near-vertical cosmic ray track could produce exactly this kind of feature. We cannot rule any of these out from a single frame, but we can say the morphology is unusual, the color is distinctive, and a full analysis would require access to the original film negative, not a digitized scan, to determine whether the mark has depth across emulsion layers, which would confirm a particle track versus a surface artifact. Object 2. Dual anomaly. Two separate sky regions, Apollo 12. This is a different frame from the same mission, similar landscape, similar astronaut shadow and frame, and this time the analysis box highlights two distinct regions of the sky simultaneously, labeled Area 1 and Area 2. Area 1 is in the left sky sector and appears essentially dark in the zoom, suggesting a very faint or marginally resolved feature. Area 2 in the right sky sector shows a faint but distinct blue-white point source, clearly differentiated from the background noise of the film grain. The fact that two separate zones of the same frame show anomalous features is significant, not because it proves anything extraordinary, but because it complicates the film artifact hypothesis. The Apollo cameras were typically set to exposure parameters optimized for the brilliant sunlit lunar surface. Under those settings, stars are simply not bright enough to register on film. Could it be Earth? Earth would be visible from the lunar surface, and depending on phase and angular position, could appear as a bright point or crescent. Object 3. The bicolor point source, Apollo 12. This one's particularly striking. Above the lunar horizon, slightly right of center, the inset reveals a small but clearly defined object showing two distinct colors, what appears to be a red component and a white or blue-white component in close proximity, almost as if two adjacent pixels are saturated in different color channels. Chromatic aberration in a lens system spreads point sources of white light into a short spectrum, with red and blue components displaced relative to each other. If this is a bright point source, a planet, a piece of space hardware, reflected sunlight from debris, and if it was at the edge of the focal plane or subject to atmospheric equivalent dispersion, there is no atmosphere on the moon, but lens glass itself introduces dispersion, you would expect to see color fringing of exactly this type. The most intriguing prosaic candidate here is the Apollo Lunar Module Ascent Stage, or another piece of mission hardware in the distance. Highly reflective metallic surfaces in direct sunlight on the airless moon can produce intense specular reflections. If a piece of equipment or even a fragment of debris from the Saturn V upper stage was in the camera's field of view at a distance, it could appear as a bright, possibly color-fringed point source. Now we get to the most complex image in the set. 5 labeled areas, 5 separate zoom-in sets, all from a single Apollo 12 frame. Area 1, faint blue elongated smear, low intensity. Area 2, 2 closely spaced blue-white point sources, a double feature. Area 3, larger, brighter blue-white point, more clearly defined. Area 4, another faint blue smear, morphologically similar to Area 1. Area 5, the most dramatic, a bright, elongated, structured object with white and blue coloration, noticeably larger than the other features and showing what appears to be internal structure or, at minimum, a non-circular morphology. Area 5 specifically demands attention. Its elongated form and apparent brightness set it apart from what you would expect from either stellar sources or simple film artifacts. If this were a cosmic ray track, the orientation and brightness profile are unusual. If it were lens flare, one would expect it to correlate geometrically with the sun's position relative to the frame, and its location in the lower right sky region would need to be checked against the solar geometry of that specific shot. During Apollo 12's mission, the command module and lunar module operated in close proximity during rendezvous phases, and small fragments of insulation, paint flakes, and ice crystals from venting were documented as persistent debris clouds around the spacecraft. Photographed from the surface, such a debris field illuminated by direct sunlight could produce multiple small reflective points, exactly the kind of distributed multi-object pattern seen in this frame. The clustering of 5 anomalies in one photograph rather than spread across the full archive also raises an interesting statistical question. Is this distribution random, or does it suggest a common source? That is a legitimate scientific question, not a conspiratorial one. Object 5. The Apollo 17 cluster. The landscape is entirely different. You can see the undulating hills of the valley walls in the background, a completely distinct terrain from the flat mare surface of Apollo 12's landing zone. And yet, above the horizon, in the upper right sky region, the inset shows a cluster of blue-white luminous objects, multiple points in close proximity, with what appears to be a brighter central concentration and fainter companions around it. Take a look at this object from the Apollo 17 mission. The fact that similar features appear across 2 different missions, separated by 3 years, with different crews, different cameras, different film magazines at a different location on the moon, is the single most scientifically compelling aspect of this entire dataset. The strongest scientific candidate for this Apollo 17 cluster, the Pleiades Open Star Cluster, a grouping of young, hot blue-white stars that would appear exactly as a compact blue-white points if captured on highly sensitive film or under overexposed conditions. Under unique exposure conditions or with film that has been slightly fogged by radiation, such a cluster could register. But the exposure conditions required for that to happen in a standard Apollo surface shot would be extraordinary, and extraordinary conditions require explanation of their own. What are these really? Scientifically honest answer? We don't know.